Alright, hello friends. We are here again. This is Mathematics Made Easy tutorial, MTH 102. This time around, we are looking at area bounded by a curve. Of course, looking at application of integration. Area bounded by a curve. Let's look at a typical example. Look at the problem before us. Find the area of the finite region between the x-axis and the curve. And the curve is given y equal to x into x minus 1 into x minus 3. We are required to find the area of bounded by the regions of this curve made with the x-axis. And the function, once again, you're looking at y equal to x into x minus 1 into x minus 3. I will take you through the steps and the rigor involved in doing this. Very simple. Step number 1. First and foremost, what you need to do is to find what I call the zeros of the curve. So first thing is finding the zeros of the curve. What do I mean? It's to equate y equal to 0 in that function and solve for x. So if y equal to 0 implies a function becomes x into x minus 1 into x minus 3 now is equal to 0. Solving that, you can see x equal to 0 or x equal to 1 or x equal to 3. So our coordinates are 0, 0, y is 0, x is 0, 1, 0, y, x is 1, y is 0, and finally we have 0, 3. 3, 0 rather. X is 0 and x is 3 and y is 0. Alright, step 2. Don't forget step 1 is to find the zeros of the function, which set y equal to 0 and solve for x. Now step 2, you now do a little sketch about the curve. Sketch the curve. Now let's sketch the curve. Now taking note, you are not doing too much rigorous sketch. You are not looking at detailed sketch, just a little sketch about the curve. What we wanted or to take note is the coordinates, the 3 coordinates that we got from the zeros of the function. Can you recall? We got number 1, we have 0, 0. At that point, y is 0, x is 0. We also got 1, 0. At that point, x is 1, y is 0. And we also got 3, 0. At that point, x is 3, y is 0. So we're using these 3 coordinates to sketch the curve. So let's look at a curve carefully sketched for us. In the curve, we have the y-axis. Of course, we are looking at 2 cm for 1 unit, and also in the x-axis 2 cm for 1 unit, though it's not taken into scale. Of course, look at this point of intersection, y is 0, x is 0. At this point of intersection, 1, x is 1, but y is 0. Finally, look at the third coordinate, y is 0, but x is 3. Now we have a sketch to join the coordinates together. Give us the beautiful graph. Now the area now we are looking at is the shaded portion of the graph. Alright, now the function before us that we used to draw the sketch the curve is y equal to x of x plus x minus 1 into x minus 3. Expanding that, we are going to have x of x squared minus 4x plus 3 multiplying x minus 1 and x minus 3. And that further gives x raised to power 3 minus 4x squared plus 3x. So this is the main function that we are dealing with. Y now equal to x cubed minus 4x squared plus 3x. Alright, finally, now let A represent be square unit, a square unit be the required area that we are looking at. Then means A equal to, now we have two regions in the curve. We have a positive region and we have a negative region. So the area bounded by the curve is the positive region minus the negative region. And the positive region ranges from 0 to 1 and the negative region ranges from 1 to 3. So the area bounded by that curve will be equal to the positive region, ranges from 1 to 0 of the function, minus the negative region, which ranges from 3 to 1 of the function. So we have integral 1 of 0 of x cubed minus 4x plus 3 dx minus is minus because this other